Hello, what's going on? Today we're solving problem 19 from the 2017 AMC 10A. Alice refuses to sit next to either Bob or Carla. Derek refuses to sit next to Eric. How many ways are there for the five of them to sit in a row of 5 chairs under these conditions? Now this problem is seemingly simple, and you have to use this. You have to kind of use a certain methodology to solve the problem, because if you just go out and say, okay, there's 5 choices for A to sit, you kind of didn't count that if A sat in the middle, then the 2 cases would be 2 and 2, and then there would be a whole different outcome, right? And so that's why you have to break it down to casework. And if you tested it out and you didn't make a careless mistake, you would have discovered that, and that's exactly what I did, and I came to the right answer when I first solved this problem. So the first case that we need to make up is where some arbitrary person is going to sit. Will the person sit in an edge sheet? Let's just say A sits in an edge sheet. Would A sit in an edge sheet? Right? And the case 2 would be A doesn't sit in an edge seat, right? Right? So if A sits in an edge sheet, then we have 2 cases. We have this one. So that's 2 cases already. We have A, B, C, D, E. So say we chose A for the first one. Alright, so let's say I chose A here. Well, then it tells me that A cannot sit, does not want to sit next to Bob or Carla, so we can only kind of preemptively eliminate these 2, and we're left with 2 more cases. So we have another 2. So we have 2 times 2. We have 2 cases here, 2 cases here. Okay. And after that, let's say I chose, I don't know, D. If I chose D, then, right, I have 2 cases. And another 2 cases, because D can't sit next to Eric, so that's going to be eliminated. We have 2 more. 2 more, so 2, 2, 2. And then the last case would be basically just 2 cases for B and C. Sorry, 2 cases for C and E. And C and E perfectly fine to sit next to each other, so it'd be 2 and then 1. So this would just sum to another 2, and then times 1, this would just sum to 16. So that's the first case, and you can already eliminate B and A because they have another case to count. So, case 2, that A sits in non-edge seat. For example, let's say she sat in the middle right here, right? Alright, she has 1, 2, 3 choices for the first one, right? Let's just remake this chart so it's more easy to understand. So we already chose A. But now we know that A can't sit next to Bob or Carla. So this one, we can't have Bob or Carla. We have to have D or E, right? So we have 2 cases, right? And then after we chose D, okay, James 2. After we choose D, we have another 1 case, okay? Let's say we chose D and then E, okay? And now we know that B and C respectively can go down the spot, so we have another 2. This could be like, for example, C, and let's have 1. We're left with 1. So that is another 12, right? So we sum these 2 up. We do 16 plus 12, and we get our answer of 28. How do you know we've counted all the cases? Well, the only possible way we're trying to see all friends is either that A sits in edge, or doesn't. Same with any other letter, and that means that's how you verify and say no vertically that you have the right answer, period.